Okay, so the topic is inequality, inequality involving modulus function, modulus function. Okay, so few things which we have to keep in mind while solving inequality for modulus function. If we have function like this, mod x less than minus less than suppose it is k. Okay, so it implies that the inequality will be x is greater than minus k and less than plus k. It will be like this. Okay, suppose if we have inequality, if we have inequality mod x less than or equals to k, then only what we have to do, instead of this strict inequality, here we will have slack inequality. Okay, like this. Now suppose if we have modulus function like this, mod x greater than k, it means x is greater than k and x is less than minus k. So we will break the inequality in this way. If we have this mod x greater than k, if it is less than k, the inequality will be like this. If it is less than or equals to k, it will be like this. If we have greater than this, then we will write it like this. Okay. Similarly, mod x greater than or equals to k, the inequality will be like x is greater than or equals to k and x is less than or equals to minus k. Okay. Now we will understand the graphical solution of these inequalities. In the first case, in the
So
first
like
case,
in first and second case, all the three variables are related, no, like negative, and then on the right side we have positive k and in between x. So like in the third and fourth cases, we have written the variables separately. So why is
yes,
it like that?
let me explain you through the number line. Okay. In the first case, it means that x is in between minus k to plus k. Okay. So all the region in this number line, which I have shaded, will be considered as are the solution region. Okay. Excluding k and minus k. Whereas in the next case, all the region including this k and minus k will be considered as the solution. Okay, solution of this inequality. Here minus k and k are included. But in this case, in the third and fourth case, let us consider the third case first. Okay, in the third case, here this point is minus k and this point is plus k. Okay, so when mod x is greater than k, so it will be greater than k when this condition is there, greater than k, or when x is less than minus k. Less than minus k means this, so this region will be the solution. So we cannot combine the two condition like this in this way. Okay, here our solution is only in one segment, whereas here our solution is in two different segment. That's why we have to write separately like this. Okay.
Yes, sir.
Similarly, if it is a slack inequality, here k will be included and graphically we have to fill this bubble, and this will be our solution in the fourth case. Okay, is it clear?
Yes, sir. Understood.
Okay. Now, let us begin with the questions first, then we will, for uh, any other properties, we will discuss while solving the questions. Okay. So, let's start with exercise 2.4, question number 1. So, in question number 1, we have to solve the inequality. The first part is mod x plus 3 less than or equals to 5. Okay. So in this case, our inequality will be like x plus 3. Whatever there is inside the modulus, we will write it like this, and it is less than or equals to 5. So we will consider greater than or equals to minus 5 and less than or equals to 5. Is it clear? By that first or second rule, we
Yes,
can
sir.
write it like this. Now we have to find the values of x. So for that we will subtract 3 from this inequality, from each term of this inequality. Now the leftmost side will be minus 8, middle term will be x, and the rightmost part will be 2. Okay. Now the solution will be minus 8 comma 2. Here both will be included, since there is a slack inequality over here. Okay. So this will be our solution.
Yes, sir.
Now in a similar manner, try to solve the second, third and fourth part.
So for this first one, we got -4 and -1.
For which one?
So this first part only done. Okay, yeah, yes, sir. I saw the different one.
Okay. Have you solved the second part of question 1?
Sir, I think I'm getting wrong answer.
Okay. Let me check that part. Okay, so here the function is like this: mod 3 minus 5x less than 7. Okay. So what we will do, we will write it like this: 3 minus 5x greater than minus 7, less than 7. Is it correct? Now we will subtract 3 from this inequality. Minus 3, it will be minus 3, it will be minus 3. Now
Sir, we
the
will take our, like, I think we should take 3 by 5, no?
Why 3 by
Because,
5?
sir, if we'll equate the equation with 0, then x's value will be 3 by 5.
No, no. Why we will equate with 0? Look, our objective here is to make this middle term x. This is our overall objective. This is how we solve the inequality. Okay. So to make this complete part as x, first we have to remove this 3. Okay. For that, we will subtract 3 from this complete inequality. This is what we have to we have solved in exercise, previous exercise 2.3. Okay. So when we subtract 3 from all the part, left part will be minus 3, rightmost part it will be 4, whereas the middle term will be here this 3 gets removed and you will get minus 5x like this. Okay. Okay. Now the next step, we have to remove this 5. For that, we will divide by 5. Complete inequality will get divided by 5. So divided by 5, divided by 5, divided by 5. Okay. Now this middle term will be minus x, whereas the left part it will be minus 2, and the right part it will be 4 by 5. Is it okay? Okay.
Yes, sir, understood.
Now we have to remove this minus sign. For that, we will multiply with minus 1 with for this complete inequality. Now, in case when we multiply with negative number, so what happens? This inequality sign get reversed. So it get reversed like this. Okay. Now, this condition says that this condition says that x should be greater than minus 4 by 5 and it should be less than 2. Okay. So the solution will be like this: minus 4 by 5 comma 2, both are not included. Okay.
Sir, if this negative sign, if we would have taken it for 2, then
We would
like
have
it would
taken,
be positive then.
which will be positive. X.
Sir, like we, yeah, the this negative sign which was for x, we have shifted it with 4 by 5. So if we'll take it with 2, then
If we shift this minus 4 by 5 here.
7, 6.
Okay.
So I was saying that like we have made this 2 positive and we got 4 by 5 negative.
Yes.
So basically we are like adding the sign on the either sides, like with 2 also and 4 by 5 also.
No, actually, we are not shifting it like that. Actually, what we are doing, we are completely multiplying with minus 1 with this complete inequality.
So
Okay.
like our x should never be negative.
No, because we have to find the values of x. Here we are getting the values of minus x. So we are supposed to find the value of x, not value of minus x. That's why we have to make this term positive. Okay. Look, if we have an inequality like this, minus x is greater than 2 less than 5. Suppose we have inequality like this. Okay. We have to find the value of x. So what we are supposed to do, we have to make this positive x. For that, we will multiply the complete expression with negative 1, minus 1. Okay, so it will be minus 2, it will be minus 5, it will be plus x. All sign gets reversed. Also, this inequality will also get reversed. This is how we get the value of x if we have negative x. Okay,
Yes, sir.
so here it means like this: x is greater than minus 4 by 5 and less than 2, and further we can write it like this. Is it clear?
Yes, sir.
Okay. Now the next third part. Now for the third part, it is mod x plus 3, x plus 1 greater than or equals to 3. Now here, this mod x plus 1 is greater than 3. So just check the cases. So here we will write it like this: x plus 1 greater than or equals to 3, and x plus 1 less than or equals to minus 3. We will write it like this. Is it clear?
Yes,
Okay.
sir.
Now here it will be x greater than or equals to 2, and here it will be x less than or equals to minus 4. Okay. Now how we will write this solution? For that, let us understand the situation we using number line. So minus 4 will be here, plus 2 will be here. Now this condition says that x should be greater than or equals to 2. So this region will be our solution according to this. Whereas in the second part, this condition says that x should be less than minus 4. So this will be our solution region. So this region will be considered as minus infinity comma minus 4, where minus 4 will be included. So this closed interval will be there. Here it will be from 2 to infinity. Infinity is obviously not included, but 2 will be included. Okay. So the final solution we can write like this: minus infinity comma minus 4 union 2 comma infinity. So this will be our final answer. Okay. Just check this.
Yes, sir.
Is it clear? Okay. Now try to solve the fourth part.
So done.
Okay. So question number one is completed. Now question number two is also similar. Just we have to show the solution in number line. So check the question number two and ask if any question you want me to solve.
Sir, but like I have one doubt here, like in this fourth part only, that when we'll draw the number line for -1 and 7 by 3, so it says that x is greater or equal to -1. That means we'll have like the numbers will start from 0 to infinity. So the shaded region will come on the right side, no?
For this fourth part,
Yes, sir. The
o-
number line.
okay, actually you will get the solution like this. X less than or equals to -1, and you will get x greater than or equals to 7 by 3. You will get the solution like this. Are you getting it like this?
No, sir, the signs are opposite.
So you might be doing some mistake, I think. Okay, let's check. Okay, so here it is mod 2 minus 3x greater than or equals to 5. Okay, so first step which we you have to do is 2 minus 3x greater than or equals to 5, and second case will be 2 minus 3x less than or equals to -5. You have considered like this. First step was like this. Okay. Now for the next step, what you have to do, just shift this 5 here and minus 3x here. Okay. So you will get 2 minus 5 greater than or equals to, it will be 3x. Okay, correct? Now this term is -3, so 3x uh, like this. Okay.
So like you have taken 3x on the other side. Now I have left it on LHS only.
Okay, no problem. If you have considered like this, so minus 3x is greater than or equals to, you are getting 3 like this. Okay.
Yes, sir.
Further, minus x is greater than or equals to 1. Okay.
Yes, sir.
Okay. Now, what we have to do? We have to remove this -1.
Yes, sir.
We cannot directly shift this -1 here. It is wrong. It is okay in case of equality, but in case of inequality, it is wrong. So for that, we have to multiply with -1 both the side. So the left part will be x, right part will be -1, and this inequality sign gets reversed. Okay. So this is how you will get x
Yes, sir.
less than or equals.
Understand.
So I think you are doing mistake right over here.
So like then in the second part, like we can directly cancel the negative sign, no, because we have on
No,
both
no,
the
no, no, no. We cannot do so. We cannot
sides.
directly cancel the negative sign. Look, what does this means? Okay, let us consider two numbers. This is -3 and this is -5. Now tell me which number is greater, -3 or -5? Which number is greater?
So -3.
-3. So we will write like this: -3 is greater than -5. Now if you just cancel this minus sign, so it means which
Mm.
number is greater? It means 3 is greater, but it is wrong.
Yes, sir.
Okay,
Mm.
so we cannot cancel minus in this case.
So again, we'll have to multiply -1.
Yes, in such cases we have to multiply with -1 and we have to reverse the inequality symbol. So it is better to avoid that situation of getting -x. It is so you can shift this term here, this term here. You will get 7 less than or equals to 3x like this. So 7 by 3, x is greater than or equals to 7 by 3. So this will be your solution. Okay. Now is it fine?
Yes, sir.
Okay. Now ask any question from the second part.
So once I'm solving this first part only.
Okay. Hello.
So got the answer.
Okay. Okay. So
So can we do the fourth part
fourth
of
part of
question number
question.
2?
Yes. Okay. Question 2, fourth part. Here it is like this: 3 mod 5 minus 2x, and it is
So
greater than.
after putting the mod in brackets, we'll multiply it with 3.
Actually, we have different ways for solving this. Look, how we can start. First step, either we can write it like this also: 5x, 5 minus 2x, sorry, 5 minus 2x greater than 7 by 3. We can directly cross multiply 3 right over here. This is step we can do. Or we can also just put this 3 inside the mod. So it will be mod 15 minus 6x greater than 7. We can also start with this. Both are correct. Further, this way of solution will be same as we have done in previous question. Okay. So can we leave this and we can start with the next part? Or yet? Okay.
Yes, sir.
Okay. So let's start with the third part, I think. So in case of third question, the first part is mod 2 plus 3x greater than 0. Okay. So in this situation, for example, if we have any number here, so how we start with this? We will write 2 plus 3x greater than that number, and second case will be 2 plus 3x greater than, sorry, less than minus of that number. We will write like this. Okay. So here also we are doing the same. Further, when we solve this, it is 3x greater than minus 2 and x greater than minus 2 by 3. Whereas in this case, it is 2 plus 3x less than 0, minus 0 is 0. So 3x less than minus 2 and x less than minus 2 by 3. Okay. Now we will combine both the situations. Okay. So the first condition says that, let us consider here that point minus 2 by 3 is here. Okay, so first condition says that x greater than minus 2 by 3. So we will shade this region. The second condition says that x less than minus 2 by 3. So we will shade this region. So the complete number line will get shaded except the one point, that is minus 2 by 3. Okay. Because it is not included in both the cases. Okay. So our solution can be r minus of minus 2 by 3. Means set of all real number except this number minus 2 by 3. Okay.
Yes, sir.
Now let's start with the second part of this question. Now the second part we have to start with the same way. Here it is 8 plus 3x less than mod 8 plus 3x. Okay. So we will start in the same manner what we have done. So first it is 8 plus 3x greater than this number 8 plus 3x, and second case will be 8 plus 3x less than negative of this number 8 plus 3x. This first step is clear to you or not? Any doubt? Clear, na? Okay.
Yes, sir.
Okay. So this situation will not be true. Why it will not be true? Because further when we solve this 8 and 8 get cancelled out, this 3x and 3x will get cancelled out, and you will get 0 greater than 0, which is not true. So we will not consider this situation. Only this situation will be considered. Okay. So further when we solve it is
Like we
minus
have just taken minus k and x one side and then again x and k on the other side.
the left part.
So like according to this rule, no, if the sign is towards the right, so we'll take minus k, which is sorry, x which is greater than minus k and k is greater than x. The first property that you told.
Uh, Look.
So
Uh,
like
like
this, the
what we
first
have
property.
when we have mod x greater than 1, uh, mod x greater than 1, yes, mod x, suppose mod x greater than l, it is like this. Okay. Or we have taken the k na, mod x greater than k. So how we will write like this? We will write x greater than k and x less than minus k. We will write like this.
So here our k will be 8 plus 3x.
Yes, here this k is 8 plus 3x, this 8 plus 3x. So in the first case, we have removed this mod, and instead of k, we have written this 8 plus 3x as it is. Okay. Whereas in the second part, again, we have removed this
Yes,
mod and we have changed the inequality, and minus k, instead of minus k, we have written like this. So you will get a solution like this. Check.
yes, sir, done.
Okay. Okay, now let's solve the last two questions from this exercise. So here the third part is mod 5x less than mod 10 minus 5x. Okay, for this we have to apply one property uh, of modulus, which is like this: if we have mod x greater than or equals to mod y, then it implies that x square is also greater than or equals to y square. Okay, so for these type of questions where both the side we are getting a mod, we will apply this property and solve. Okay, so what we will do here, we will apply the squaring both the sides, so it will be 5x whole square less than, it will be 10 minus 5x whole square. Okay, clear is it? So in the left hand side it will be 25x square, whereas in the right hand side we will apply a minus b whole square. So it will be a square plus b square minus 2ab. So it will be minus 100x. Okay. Now this 25x square and 25x square gets cancelled out. And further we can shift this minus 100x right over here. So it will be 100x less than 100. Further you will get x less than 100 upon 100. So you will get x less than 1. Okay. That's it. This will be your solution. Or we can write like this: minus infinity comma 1. Okay. Now try to solve the
Yes, sir.
last part in the same way which we have solved in the third part. Got the solution?
Yes, sir. Got it.
Okay. So that's it. The next exercise 2.5, we have already done that exercise. You might have remembered before
Yes, sir.
starting with LPP. Okay. Now one more exercise is pending from this chapter, that is 2.1. Okay.
Yes, sir.
So we can complete that exercise also today. Okay. So for that first you have to look at the chart which is given in page number 68. Okay, one table is given in page number 68 in which you can see the statement on the left column and the conclusion which can be drawn in the right side column. Okay, so just we have to understand this situation, and based on that we have to draw the conclusion. So if a is greater than b and b is greater than c, then we can conclude that a is greater than c. It is simply like, if there are three person, the first person is greater than the second and second is greater than the third, then we can conclude that first one is greater than the third. Okay, so same type of conclusion can be drawn from this type of situation. Whereas the second row, or the second conclusion which you can see for different statement, like a is less than b and b is less than c, then we can draw like this: a is less than c. And different other situations are also given here, so you can all the situations the conclusion is same. Okay, so just keep this table in your
Yes, sir.
mind, and further we can solve the exercise 2.1. Okay, now start with the exercise 2.1, question number 1. Okay, so question number 1. Okay, for question number 1 to 5, what we have to do? We have to check whether the given conclusions are correct or not.
So
So,
like in place of ABCD, we can assume values also, no?
yes, we can assume the values. Okay, so here the first statement says that C is equals to B, greater than or equals to A, and less than or equals to D, and it is equals to E. This is our statement. And now the first conclusion says that C is equals to X. And the second conclusion states that C is less than D. So look, what we can see, this C and X. So in the given statement, nowhere X is there. So we cannot conclude anything about X. What is X? We don't know. So this conclusion is not true. This conclusion is not true. Okay. Now we will check for C less than D. We will check whether C is less than D or not. Okay. So here C is equal to B. So we can replace B with C. So this will be the C. Okay. Now this statement is C greater than or equals to A, and D is also greater than or equals to A. So here C and D both are greater than A, but there is no relation between C and D, whether they are greater or smaller. So this statement is also not true. This conclusion is also not true. Correct? Okay. Now let us check for the second statement. Second statement says that P is greater than Q, comma, T is less than or equals to R, and R is less than S, and S is greater than P. The statement is like this. Now, first conclusion says that P is less than or equals to R, and second says that T is greater than S. So we will check for the two conclusions. First, we will check for P and R. So the relation between P and S is given here, and S and R, the relation between S and R is given here. So this, when we combine the two relation, it says that S is greater than R and S is greater than P. Okay, so S is greater than both R and P, but there is no relation between uh, P and R properly defined. So we cannot conclude with this. So this conclusion is not true. Okay. Now we will check for T and S. So for T and S, yes, look at this. T and S. Here, T is less than or equals to R, and R is less than S. Okay. So obviously S is greater than T. Okay. S is greater than T. So conclusion will be like this. But here the conclusion statement is opposite to the conclusion, actual conclusion. Okay. So this conclusion is also not true. Is it clear?
Yes.
Okay. Now let's move to the third part. The third question says that uh, statement says that B is greater than C, C is less than or equals to E, which is equals to D, and B is equals to F, which is less than A. Okay. Now the first conclusion is A is greater than C, and the second conclusion is E is less than A. Okay. So less than or equals to A. So let's check with the situation A and C. So how A and C are related. Okay. So here A is greater than F and F is equal to B. So we can replace this F with B. So indirectly A is greater than B. Okay. Now B is greater than C. So we can write B is greater than C. Okay. We can write like this. So here it clearly says that which one is greater? A is greater than C. So this first conclusion is true. Okay, is it clear?
So once again, can you explain this part?
Okay, let us understand from this. Okay, so here A is greater than F and F is equal to B. So I'm just replacing F with B. So we can write like this: A is greater than B. Okay.
Yes, sir.
Now, the relation between B and C is like this: B is greater than C. Okay. So we can write like this: B is greater than C. Okay.
Hmm. Yes, sir.
Now, A is greater than B and B is greater than C. So obviously A is greater than C. So yes, A is greater than C is true.
So if we consider like this question, like if we replace it with number, then how can we prove that A is greater than C?
We will consider different numbers. So now, just consider A is equal to 10 and B and F consider it as 7. Okay, so here A
Yes,
is
sir.
10, 10 is greater than 7, and that is equals to 7. B and F both are 7. Okay, now consider C, which is less than B. So B is 7, consider C as 5. So C will be equals to 5. Clear?
Yes, sir.
Now C is 5 and A is 10. So which one is greater? 10 is greater than 5, means A is greater than C. So it is true.
Yes, sir. And so when we have this condition that E is greater or equal to C, that means the value for E can be like either 5 or any value above than
Yes.
5.
Uh, Actually, E is greater than C. Here the condition is E is greater than C. So here
So then
C,
equal to
C,
also, no?
yes, greater than or equals to C. So we can consider 5 or 6.
Yeah. Yes, sir.
E can be 5 or 6, anything. Okay. So yes, this condition is also true. Okay. No, just wait. E is greater than, just wait. Second condition may not be true. We cannot conclude anything about this. Okay. Because E can be 11 also, na? Here it
Yes,
says
sir.
that E is
Yeah.
greater than or equals to C. So E can
Mm.
be 11 also. It is not necessary that it is less than 10.
And
Okay.
so, like in this equation, the CBA1, where you have put that arrow,
Yes.
like here in the question, the statement says that A should be greater than C.
Yes.
Sir, so where we have changed the sign.
No, we have not changed the sign. Actually, we can write like this. We can remove this B from here. Okay, and
Yes,
we
sir.
can write A is greater than C. We can write like this. Okay, if I am
Yeah,
writing like
yes,
this, A
sir.
is greater than C, if I am writing like this, then both mean same.
Yes, sir.
Okay, okay, is it clear?
Yes, sir. Understood.
So the second part is not true because there is no relation between E and A. That's why. Okay. Now let's move to the next part, the fourth part. Here the statement for the fourth part is B is greater than or equals to D, which is less than C, which is greater than E, which is equals to F, which is less than or equals to A. Okay. Now the first conclusion says that D is greater than A, and the second conclusion states that C is greater than F. Okay. So we will consider the first. Let us check for the first. D is greater than A or not. Okay. So D is less than C. Okay. So actually this situation, for this situation, look what is given. D is D is less than C. Okay. And E is also less than C. E is also less than C. Okay, we can replace E with F also because E and F both are equal. So we are just replacing E with F, and A is less than or equals to F. Okay, it is like this. Okay, so according to this situation, A is greater than F. Okay, so no conclusion can be drawn between A and D because this inequality signs are different. Here it is, this these two inequality signs are different. How we can concluding this part? Just look at the table. Okay, just look at the table in page number 68. In that table, in the last row, which you can see. Okay, so in the last row, when no conclusion can be drawn, so look at the cases when the inequality signs are opposite to each other. In that case, we cannot draw the any conclusion. When inequality sign faces in the same side, then only we can draw some conclusion. Here we can see that inequality sign are opposite to each other, so in such cases we cannot draw any conclusion like this. Okay, is it clear?
So that means for that D is greater than A, that means the entire equation which is given to us, so that will be incorrect. Like starting from B is greater than D, and then the last one A is greater than F. Like the entire equation will be incorrect, or till where we have to take that the
No,
equation.
no, actually we cannot say the inequality is incorrect. We says that we cannot draw any conclusion from this. Okay, because no conclude, look, if I have some condition like this: A is greater than B, B is greater than C, C is greater than D, like this. Okay, then obviously I can conclude that A is greater than D. Okay, if the inequality sign is on the same side, then we can conclude, we can draw some conclusion between the first and this last term.
Yes,
Okay,
sir.
but if it is like this, D is greater than C, but C is smaller than B, and B is less than A. So if the inequality signs are opposite to each other, then conclusion cannot be drawn from this. Okay,
Yes, sir.
so in this situation, this conclusion cannot be drawn. So this conclusion cannot be true. Okay. Now let us check for the C and F. So look, for C and F, we will consider only this condition. Okay, between C and F. So it says that C is greater than E, which is equals to F. Okay. Now we can replace E with F also. Okay. So here it will be C is greater than F. Now this conclusion is true or not? It is true. Okay. So this
Yes.
conclusion is true now. Okay, so whichever conclusion is there, you have to check that conclusion according to the statement. If you are getting same side symbols, same facing symbols, then we
Yes.
can draw as any conclusion. Okay. Okay, now let's move to the fifth part. So the fifth question is: K is less than H, which is greater than G, and G is less than or equals to N, and N is equals to U. Now, the first conclusion says that K is equals to U, and the second conclusion states that H is greater than N. So, let us check for both the conclusions. Okay, so K is equals to U. So first we will merge all the conditions. Okay, so if we merge it, it will be like this. So no, sorry, H is greater than G. Okay, now G is less than or equals to N. I am combining the two conditions, and this N is equals to U. So single statement will be like this. Okay, now what is relation between K and U? So this is K and this is U. Okay, we can replace N with U also. So it will be K, H is greater than G, less than or equals to U. I am replacing N with U because both are equal. Now clearly you can see that in this complete statement, the inequality signs are not facing only one side. It is opposite in some situations. Okay, so we cannot draw any conclusion between K and U. Okay, if this sign face toward this G, then only we can draw some conclusion. But here the faces are opposite, so no conclusion can be drawn from between K and U. Is it clear? Still having doubts?
Yes, sir. Understood.
Okay. So this conclusion is not true. Okay, now we will check for H and N. So where is H and N? So here we will consider these situations H and N. So H is greater than G and G is less than or equals to N. Again, the inequality signs are not on the same side, facing not on the same side. So no conclusion can be drawn from this also. Okay, so this situation is not true. This conclusion is also not true. Clear?
Yes, sir.
Okay. Now for the question 6 to 10, here it is indirect way. Actually, there are two types of inequality. First one is direct inequality, which we have seen in question number 1 to 6, 1 to 5. And the second is coded inequality, which is in question 6 to 10. So here the coding is like this. A at the rate B means A is less than B. Okay. Next is A ampersand B. It means A is greater than B. Next is A dollar B is means uh, A is equals to B. Next is A hash B implies A is less than or equals to B, and the last one is A percentage B implies A is greater than or equals to B. So we just need to decode this symbol, and further we have to do the same thing which we have done in question number 1 to 5. Okay. So try to
Yes.
solve any question you want me to solve from the 6 to 10, then ask any question
The
or you
first one only.
okay, the sixth question. Okay. So
Yes, sir.
okay, so let's start with that question. So the question number 6 statement is A, this is dollar symbol, B hash, next is P percentage, D dollar Q. Okay. Now the statements are conclusions are first one is A dollar P. Now the second part is uh, A at the rate P. Okay. So first what we will do, we will change this statement as per the coding given to us. Okay. So the statement will be like this. This will be A. Instead of this dollar, we will write equals to. So A is equals to B. Instead of this hash, we will write apply this symbol. This will be P. Instead of percentage, we will apply this symbol greater than or equals to. This is D. And instead of this dollar, again we will apply equals to B. Okay. Now in the conclusion also, it is A dollar means equals to. So A is equals to P. Here A at the rate will is A is less than P. Okay. So there are two
But we
conclusions.
again have that condition of where we have this sign facing towards each other for P.
Yes.
So
Repeat.
for P, we have the signs facing towards P only. No, so like it will be non-conclusive.
Uh, okay. So the answer you are asking about the answer. Okay.
No,
S-
sir. For the this P where we have written P, no, and
yeah.
the signs are facing towards each other. So like
No,
again, it will be non-conclusive or what?
no. Actually, look. If we have to draw the conclusion between B and D, then it will be non-conclusive in that case.
Okay.
Okay. But look, actually it is Q, it is not B, it this part is Q. Okay. So if we have to draw conclusion between B and D, then it is non-conclusive, because between B and D this signs are facing in opposite directions. Okay. But
Yes,
check
sir.
the conclusion. In case of conclusion, it is asking to draw the conclusion between A and P. Okay, so we will check for A and P only. In case of A and P, what we can do, we can replace B with A. Okay, so this will be A is less than or equals to P. Okay, is it correct? Okay, now
Yes, sir.
here we are getting only one inequality. Okay, so we can draw some conclusion. The conclusion is either A is less than P or A is equals to P. Less than or equals to P. It means like this. So either the first conclusion is true or the second conclusion is true. The answer will be like this. Because first conclusion says that A is
Yes,
equal
sir.
to P. Second says that A is less than P. So either any of the two conclusions is true. Okay.
Yes, sir.
Any other question?
No, sir, rest all I will try to solve it.
Okay.
And sir, like all these symbols are like universally true, that dollar
No,
sign
no, no, no,
and
no.
hash sign.
No, they are not universally used symbols. Actually, they can be coded differently in different questions. So that coding will be given to you in question. Okay.
Yes, sir. And sir, all these, that table which was given, so
Yes.
we have to like memorize it, or only certain cases that you
No,
told
no.
occasionally.
Actually, we don't need to memorize that table. Actually, we can directly use that in that way. What we have explained you, what I have explained you. Like
Yes, sir.
if we are facing in the same side, then we can draw some conclusion.
So
That's
like this like for example, if we have to prove that a like some relation between either a or d or a or q, then in that case what?
A and D. Yes. So we
Yes, sir.
cannot draw any conclusion between A and D because in between we are having inequality which is facing opposite to each other.
Yeah.
Okay. Similarly, same for I think B and Q. In case of B and Q, the inequality are facing opposite to each other. Then here also we cannot draw any conclusion.
Yes, sir.
Okay. Any other doubt from this?
No, sir, I'll solve the rest questions.
Okay. So I think we can end this session, and from the next class we can start with any. Okay, tomorrow I'm conducting a revision session for class
Mm.
12th batch for that determinants part. Okay, solution of system of equation using determinant, that adjoint of matrix, calculation of inverse of a matrix, and then further solution of equation. Okay, so I will share the timing and you
But
can
I
join.
think inverse is omitted, no?
No, inverse of a matrix is not omitted. I think calculation of inverse using elementary method is in
Yeah,
omitted.
yeah, yes, sir.
It is not elementary method. It is adjoint method. So that part is not omitted. Okay.
Yes, sir.
Okay then.
Thank you, sir.
Next chapter. Which chapter you want me to start in this batch? Applied maths batch.
So I think one, two chapters were left, no? Like number inequalities is done.
I
I
think
guess probability.
I think only probability is due. All other chapters are we have completed. I think. Okay.
Yes, sir.
So we will start with probability from next class. Okay.
Yes, sir.
Okay then. Thank you.
Thank you, sir.
Welcome.